Rigid motions are transformations which move a shape by either reflecting, rotating, or sliding that shape, which is called a translation, and keeping the sides of the shape and the angles of the shape exactly the same or congruent. A reflection, which flips the shape over what's called the line of reflection, kind of like in mirror image, is a rigid motion. A rotation, which turns the shape around a point and can turn either clockwise or counterclockwise, is a rigid motion. A translation, which slides a shape up, down, left, or to the right, is a rigid motion. However, a dilation is not a rigid motion since it changes the shape's size, which changes the length of its sides. Let's look at some examples of reflections, rotations, and translations of a shape and reflect on the coordinates or ordered pairs. If we have a pre-image, the before shape of a triangle ABC, we're going to look at the results of reflecting, translating, or rotating a triangle on the coordinate points. For the first example, we have a reflection. Now, there is a rule for this reflection that tells what happens to the ordered pairs. If we look at each vertex or corner point on the triangle ABC, and then look at the resulting coordinates in the triangle RGD, we can see what happened to the ordered pair. The point A was at -2, 5. Remember, the x-coordinate comes first and the y-coordinate comes second. After flipping that triangle over the x-axis, the point A became the point R in the image at the bottom. The point R is at -2, -5. So we can see it's the exact same coordinates, only the y-coordinate 5 went from positive to negative. The point B was at -1, 3, and after flipping or reflecting that triangle over the x-axis, it became the point G, which is at -1, -3. Once again, everything's the same except that the y-coordinate went from positive to negative. This same result can be seen when the point C at -5, 1 was reflected down to the point D at -5, -1. This shows clearly the rule that the point xy becomes the point x, -y, meaning that the y-coordinate goes from positive to negative. If we were to reflect this triangle over the y-axis, the rule would be different, as well as if we reflected it over the line y equals x. Each reflection has a different rule for what happens to the x and y coordinates, so pay attention to the before coordinates and after coordinates to see the rule for that reflection. A translation is going to move the shape up, down, left, or to the right. In this case, the triangle ABC has been shifted down and to the right. We can see that the point A, which starts at -8, 5, becomes the point G, which is at -5, 0. The x-coordinate, because this was shifted to the right 3, is going to add 3. -8 plus 3 is -5. The y-coordinate subtracted 5 and went from 5 to 0 because the shape was shifted down 5 squares. We'll see that same pattern when we look at point B, which is at -2, 4, which got shifted to the right 3 and down 5 and became the point H, which is at 1, -1. We added 3 to the x-coordinate and subtracted 5 from the y-coordinate. Likewise, point C, which is at -4, 1, was shifted to the right 3 and down 5, becoming the coordinate I, which is at -1, -4. So we added 3 to the x-coordinate and we subtracted 5 from the y-coordinate. Each translation has its own rule, but the x-coordinate we will add to move to the right and subtract to move to the left, and on the y-coordinate we will add to move it up and subtract to shift it down. The last we're going to look at is a rotation, which turns the shape. In this case, the triangle ABC has been turned or rotated 90 degrees counterclockwise. We can see that the point A, which is at -4, -1, was turned or rotated to become the point T, which is 1, negative 4. Point B, negative 3, negative 7, turned to become point K, 7, negative 3. And point C, which is at negative 5, negative 6, was turned or rotated to become point H, 6, negative 5. Looking carefully at the coordinates, we can see that the pre-image or before point going to the image or after point had the x and y coordinates switched, and we changed the sign on the first one. So negative 4, negative 1, we switched the 4 in 1 places, and the negative 1 became positive. On point B, negative 3, negative 7, we switched the 3 and the 7, and the 7 became negative. And on point C, we switched the 5 and the 6, and the 6 became negative. Sorry, the 6 became positive. The rule for this is that xy becomes negative yx because we switched the x and the y places and changed the sign on the y. Look very carefully at the before coordinates and the after coordinates to recognize which rule is taking place. Each rotation is different depending on how many degrees you rotate and which direction, clockwise or counterclockwise.